Friends, hope you all are doing well. Welcome to Ace Tutor Point. Today we'll go through atoms and molecules and the structure of the atoms. From Dalton's indivisible particles to Bohr cells, everything you need to know about atoms, molecules, ions, and how atoms are built. So today what we'll cover in this session is origins and laws, Dalton's theory and atoms, molecules, ions, formula, mole concept, structure of the atom, valency and isotopes. So, starting from ancient ideas about matter. Long before modern chemistry, Indian and Greek philosophers debated whether matter could be divided forever. So, Indian philosophy, Maharishi Kanand postulated that dividing matter rapidly leads to the smallest possible particle, which he named Parmanu. Pakuda Katyayama elaborated further. These particles normally exist in a combined form, giving rise to the various forms of matter we see. Greek philosophy in the same era, Democritus and Leucippus suggest that dividing matter eventually reaches particles that cannot be divided further. Democritus called these indivisible particles atoms, Greek for indivisible. But these were philosophical ideas without experiments to prove them. So, laws of chemical combination. Antoine Lavoisier laid the foundation of chemical science by establishing two fundamental laws. The first law is the important, that is law of conservation of mass. Mass can either be created nor destroyed in a chemical reaction, verified via activity. Reacting solutions of chemicals like sodium sulfate and barium chloride in a sealed flask. Mass before and after the reaction stays exactly the same. Next is law of constant, that is definite proportions. In a chemical substance, the elements are always present in a definite proportion by mass. For example, water always has hydrogen and oxygen in a 1:8 mass ratio, whether made in the lab or found in nature. Example, 9 gram water equals to 1 gram hydrogen, 8 gram of oxygen. So, Dalton's atomic theory 1808. John Dalton based his theory on the laws of chemical combination, giving atom a solid scientific foundation. So, all matter is made of very tiny particles called atoms which take part in chemical reactions. Atoms are indivisible particles which cannot be created nor destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms in a given compound are constant. So, next we'll go through symbols and atomic mass. So, IUPAC symbols. Every element has a unique symbol. First letter capital, second letter if any lowercase. So, H symbol of hydrogen, Ca symbol of calcium, Na sodium, O oxygen, Al aluminium, Fe that is iron. In Latin word we'll call ferrum. Atomic mass unit that denoted by U, small u. Since atoms are unimaginably small, their actual mass can't be weighed directly. So, a relative scale is used. It's an unimaginary small. 1 atomic mass unit 1 U equals to 1 upon 12th the mass of the 1 atom of carbon, that is 12. Adopted by IUPAC in 1961 as the internationally accepted reference standard for atomic mass. The mass is given below as an example, that is H equals to 1 U, O oxygen that is 16 U, C that is carbon 12 U, Na sodium 23rd U, and Ca that is calcium has 40 U. How big are atoms? Atom's radius is measured in nanometers. 1 nanometer is equals to 1 upon 1 raised to 10 raised to 9 meter. Here's a comparison of relative sizes. Atom of hydrogen that is 10 raised to minus 10. Molecule of water that is 10 raised to minus 9. Molecule of hemoglobin that is 10 raised to minus 8. Grain of sand that is 10 raised to minus 4 meter. Ant 10 raised to minus 2. Watermelon 10 raised to minus 1 meter. So further we'll go molecules and atomicity. A molecule is the smallest particle of an element or compound capable of independent existence. Atomicity number equals to number of atoms in one molecule. Monoatomic. We all know mono means one. So monoatomic, that is one atom, either argon or helium. Diatomic, that is two atoms. Oxygen always in diatomic, O2. Hydrogen H2, nitrogen N2. Triatomics, three atoms. You all know ozone. Ozone has symbolic O3. Tetra, that is 4 atoms. Phosphorus P4. Polyatomic, many atoms. Sulfur S8. Next coming ions. So there are two types of ions, cations and anions. So an ion is a charged particle, a group of atoms or a single atom carrying a net positive or negative charge. So cations denoted by plus. It has always positively charged ions formed by losing electrons, that is sodium Na plus, potassium K plus, calcium Ca2 plus, magnesium Mg2 plus, ammonium polyatomic, that is NH4 plus. And next is anions minus, negatively charged ion formed by gaining electrons. Cl minus, that is chloride, O2 minus oxide, S2 minus sulfide, OH minus hydroxide, SO42 minus, that is sulfate, polyatomic. Writing formula, the criss-cross method. Cross the valencies, that is charges of the two ions to become each other's subscripts. Then simplify. Mg2 plus multiply by Cl minus. Cross valencies is MgCl2. The 2 plus charge will go through Cl, and then Cl is the 1 charge, minus 1 will go through Mg. So we'll get magnesium chloride has MgCl2. Next example is Al3 plus multiply by O2 minus. So the 3 plus of Al will go through oxygen, and the oxygen, that is 2 minus, will go through Al. That is a cross method. Al2O3, that is aluminium oxide. Na plus multiply by CO3 2 minus. The crossed valencies is Na2CO3, sodium carbonate. Ca2 plus multiply by OH minus. Cross valencies will be CaOH2, that it made calcium hydroxide. Next is molecular mass and the mole. So what is molecular mass? The sum of the atomic masses of all atoms in a molecule of the substance, expressed in atomic mass units. So example is water. Its molecular formula is H2O. So mass of H2O is 2 multiplied by 1 plus 1 multiplied by 16 is 18U. The mass of hydrogen is 1 and the mole is 2. That is why we multiply 2 multiply 1. And the mass of oxygen is 16 and oxygen is only 1 in mole. So 1 into 16. We'll add both, we'll get 18U. So the mole is a counting unit like a dozen, but for atoms and molecules. Introduced by Ostwald in 1896. 1 mole, that is Avogadro number, has 6.022 into 10 raised to 23 particles. Molar mass equals to mass of 1 mole of a substance equal to its atomic or molecular mass expressed in grams. The mole bridges 3 worlds: number of particles, mass in grams, number of moles. So number of particles, that is capital N. N equals to small n multiplied by Avogadro number. Number of moles, that is small n, equals to given mass upon molar mass. The mass in grams, that is small m, equals to n multiplied by molar mass. So the Avogadro number, as I already said, is Na, denoted by N, capital N and small a, 6.022 into 10 raised to 23. 1 mole of carbon is 12 into G. We have 12 atoms. So we have 6.022 into 10 raised to 23 atoms. Next is discovering charged particle in matter. Simple activities like rubbing a comb on hair or a rod with silk cloth show that matters contain charged particles. Canal rays, discovered by Goldstein in 1886. These rays led to the discovery of positively charged subatomic particles called protons. Proton minus mass is 1U. Charge is +1. Discovered through experiments with gas discharge tubes at low pressure, revealing positively charged radiation opposite in direction to cathode rays. Electron, that is J.J. Thomson discovered the electron, a negatively charged subatomic particle roughly 2000 times lighter than a proton. Electron minus mass 0, negligible. Charge is -1. An atom taken as a whole is electrically neutral. The number of proton equal to the number of electrons. So the most important topic is Thomson's model of the atom. This topic is also important, and it's also asked to B.Ed students in their examinations also. So the Christmas pudding or watermelon model, also called this Thomson model watermelon model, came in 1904. So Thomson proposed that an atom consists of a positively charged sphere with electrons embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Its limitation is, although the model explains that atoms are electrically neutral, the results of experiment by other scientists like Rutherford could not explain by it. So what's the Rutherford gold foil experiment? Fast moving alpha particles were directed at an extremely thin gold foil, just a few atoms thick. First is most particles pass straight through, showing that most of the space inside an atom is empty. Second is a small fraction deflected by small angles. indicating a positive charge at a center repelling the alpha particles. Very few particles bounce straight back, that is the third one, about 1 in 12,000, showing a very small, dense, positively charged volume in the nucleus. So, Rutherford's nuclear model. The model proposed a positively charged center called the nucleus. Nearly all the mass of the atom resides here. Electrons revolve around the nucleus in well-defined orbits like planets around the sun. The size of the nucleus is very small compared to the overall size of the atom. Drawbacks of the model: an orbiting, accelerating charge should radiate energy. So, electrons should lose energy and spiral into the nucleus, that is, atoms should be unstable. But atoms are known to be quite stable. These contradicted classical electromagnetic theory. This gap was resolved by Niels Bohr's model. So, third one is Bohr's model of the atom come in 1922. So, the first postulates of these is only certain special orbits known as discrete orbits are allowed for electrons inside an atom. While revolving in these discrete orbits, electrons do not radiate energy. And the third is these orbits shells are called energy levels and are represented by the letters K, L, M, N or small n equals to 1, 2, 3, 4. K, that is N1, L, that is N2, M, that is N3 and N, that is N4. Distributing electrons in shells. So the 2n raised to 2 rule. Maximum number of electrons in the shell, that is 2 n raised to 2, n equals to shell orbit number. K is n1, that is 2 into 1 raised to 2, 2 into 2 raised to 2, 2 into 3 raised to 2, 2 into 4 raised to 2. Sample electron distribution as you are showing on the screen, that elements are there, that is sodium, magnesium, chlorine, argon. Its chemical formula is there, its atomic number is there and its electron number in the cells are there. Valency, combining capacity, determining by the number of electrons in the outermost shell. Understanding valency. Atoms react to achieve a stable, fully filled outermost shell, that is an octet of 8 electrons. This is what drives valency. Losing electrons, sodium Na has 1 electron in its outermost shell. It loses it to attain a stable octet, valency 1. Gaining electrons, chlorine, that is Cl, has 7 electrons in its outermost shell and its gain 1 more, than valency equals to 1. Sharing electrons, that is carbon, has 4 electrons. It often shares electrons with other atoms rather than losing gaining. Valency is 4. Atomic number, isotopes and isobars. So, atomic number is denoted by capital Z. The number of protons in the nucleus of an atom defines the elements. Mass number, that is capital A, sum of the number of protons and neutrons in the nucleus. Isotopes, atoms of the same element with different mass numbers. Example, hydrogen has 3 isotopes: protonium, deuterium, tritium. Isobars, atoms of different elements with the same mass number but different atomic numbers, that is calcium and argon. Both have mass number 40 but different number of protons and electrons are there. So, the last is key takeaways of this session. What we have learned, the recap of atoms and their structure. So we have learned Dalton's atomic theory built on the laws of conservation of mass and constant proportions. Every element has a unique symbol. Atomic mass is measured relatively to carbon 12. Formula are written by balancing the valency charge of ions using crisscross. A mole is equal to 6.022 into 10 raised to 23rd particles. Avogadro number, bridging mass, moles and particle count. Next is Thomson, Rutherford and Bohr's model. Progressively refined our picture of the atom. Last is electrons field shares, that is 2 and 2 rule. Valency, isotopes and isobars follow from atomic structure. So this is it from today's session. Hope you have learned something new and that has increased your knowledge. Please like, share and subscribe and press the bell icon to never miss an update.